So this lesson we're going to look at section 4.1 on graphing linear equations in two variables. By making a t-table of values. So this winds up being fairly straightforward. We notice that we start with the idea of the rectangular coordinate system. Consists of an x-axis, the horizontal axis, and a y-axis, the vertical axis. And so we'll typically think of that as the positive x-axis, negative x-axis, positive y-axis, negative y-axis. So we notice above the horizontal line is the positive y-axis, below the horizontal line is the negative y-axis. To the right of the vertical line is the positive x-axis. To the left of the vertical line is the negative x-axis. And so we'll typically give that a set of numbers. So we could say 1, 2, 3, 4, 5. Then we could have negative 1, 2, 3, 4, negative 5. Positive 1, 2, 3, 4, positive 5. Negative 1, 2, 3, 4, negative 5. And then we can make the scale whatever we want it to be, whatever winds up being convenient. We notice that we can plot points. A point in the xy plane. So I should mention the rectangular coordinate system is also called the xy plane. A point in the xy plane is given by an ordered pair xy. And we notice that the horizontal coordinate always comes first, vertical coordinate always comes second. So we notice that if we went to point 3, 5, we would look at going horizontal 3 units, going vertical 5 units, and we get the point 3, 5. So let's name that A. So the point A is at 3, 5. Then we could decide the point B might be negative 2, 0. And so we find negative 2 on the x-axis, and then we stay on the x-axis to indicate that we're not going anywhere vertically. So then if we had C was 1, negative 3, we'd find x is 1, y is negative 3. Whoops, so we've got point B at negative 2, 0. We've got point C at 1, negative 3. And then if we want to say point D is at 0, 2, we find we don't go anywhere along the x-axis and just go up 2. And we notice that that's point D, and we call the center, the point 0, 0 is called origin. The origin O is at the point 0, 0. We also notice that we can define the plane in quadrants. We notice that when we think about the xy plane, we decide that quadrant 1 or Q1 is the set of points x greater than 0, y greater than 0, quadrant 2, or Q2 has x less than 0, y greater than 0, quadrant 3, or Q3 has x less than 0 and y less than 0. And then quadrant 4, unsurprisingly, has x greater than 0, y less than 0. And so we notice we can tell what point a quadrant is in just by what sign the coordinates have. So we notice that 3, -2 is in quadrant 4. 4, 3 is in quadrant 1. -2, -7 is in quadrant 3. And if we said -1, 5, that's in quadrant 2. We're going to be careful. If we were going to say the point 0, 3, that's not in any quadrant. The point 0, 3 is on the positive y-axis. If we said -4, 0 is on the negative x-axis. So you have to be careful that points that are on the axis are not counted as being in any quadrant. So then we want to think about linear equations in two variables. We have a couple of ways to think about these. The main issue is that we can always write a linear equation in two variables in the form ax plus by equals c. And so it may not look like that. We could have 3x plus 2y equals 6. We could have y equals 2x plus 3. We could have x equals y plus 4. You notice that that first one is already in the correct form. The second one we could rewrite as -2x plus y equals 3. The third one we could rewrite as x minus y equals 4. What we notice is that in all three cases, the variables have an exponent of 1. So linear equations the exponents on variables are at most 1. So technically we could say y equals 4 is a linear equation and x equals 2. These are both linear equations, and we'll talk about those a little bit later. So in particular, we notice that if we said something like x squared plus 2 equals y, or y squared minus 3x equals 7, are not linear equations because they have exponents higher than 1. We'll talk about those later. Those two are actually called quadratic equations, but we're not worried about those for right now. And then, especially if we go even higher than 2, it's really not a linear equation. So y equals x cubed minus 3, y equals square root of x plus 4, again, not linear equations. So I should actually specify that when we say exponents are at most 1, we really want to say that the exponents on the variables are going to be 1 or 0. So basically, we can either have x and y both, or just x or just y. So if we want to try to graph a line, if we want to try to graph a line using a table of solutions, we notice we can look at something like y equals 3x plus 1. We notice that we write a table, x equals, y equals, and so this is why we call it a t-table. We have a big T where it's separated into x values and y values, and we can just write down arbitrary values of x. We can say x is negative 2, negative 1, 0, 1, 2, and then we notice the corresponding y values. We get 3 times negative 2 plus 1, 3 times negative 1 plus 1, 3 times 0 plus 1, 3 times 1 plus 1, 3 times 2 plus 1, and so we get our y values are negative 5, negative 2, 1, 4, and 7. And we notice that gives us 5 points. We can then graph those. We notice that we're getting x values go from negative 2 to positive 2, and our y values go from negative 5 to negative 7. So we can plot the point negative 2, negative 5. We can plot the point negative 1, negative 2. Plot the point 0, 1. Plot the point 1, 4. Plot the point 2, 7. And we notice that as long as our scale is pretty much, our graph is reasonably accurate, we're going to get a fairly straight line. And so on quizzes and exams, you'll get a nice grid to work with. So then, if we tried y equals negative 2x plus 3, we notice the same sort of thing happens. We're going to get x equals, y equals. We notice we only actually need 2 or 3 points to make this work. If we tried negative 1, 0, 1, we get negative 2 times negative 1 plus 3 gives us 2 plus 3 equals 5. Negative 2 times 0 plus 3 equals 3. And negative 2 times 1 plus 3 equals 1. And so we only need 2 points to make a line. We usually just get 3 points to verify. So we notice that if we've got negative 1, 0, and 1, and then we have the point negative 1, 5, 0, 3, and 1, 1, we notice those all look like they're going to land on the same line. if we had accidentally gotten, if we had accidentally gotten the 0.15, we notice that that looks wrong. And so by having the 3 points, we can tell if one point looks like it's not in the right place. And we notice that linear equations and two variables are pretty much always going to be straight lines. So if we get something that doesn't look like it's going to be a straight line, we know something has gone wrong. One of our calculations is off. We also notice that if we have things where we only have one variable, we said 3x equals 9 or 2y equals negative 4, things like this, we notice when we solve it, we get x equals 3. For the first one, we get y equals negative 2 for the second one. And we notice when we're graphing these in the xy plane, in the rectangular coordinate system, when we say x equals 3, we're literally saying the horizontal position is fixed, we know x has to be 3, and y can be anything it wants to be. And so if we wanted to set up a t-table, we'd basically be saying x equals, y equals, and we'd say y is negative 2, 0, 7, x is, for any of those, is 3. So no matter what y is, x is 3. And similarly, for the y equals negative 2, we're saying that the vertical position is fixed at y equals negative 2, and x can be anything. And so we get a horizontal line. Again, the t-table would look like x equals y equals negative 7, 0, 4. We notice that y is negative 2 regardless. And so in general, we notice that x equals a is graphed as a vertical line through the point a0, and y equals b is graphed as a horizontal line through the point 0b. And so we notice in general, we're looking at something like arbitrary a with a y coordinate of 0, and then we just draw a vertical line. Y can be anything. And then we notice that for y equals b, we find b, and then draw a horizontal line through it. So in general, you'll notice that if you tried drawing two horizontal lines and they look the same, you notice something has gone wrong. So you notice that if you tried saying graph x equals 3, and you found x equals 3, and drew a line like this, going horizontally, you notice that would look the same as x equals 5, that tells you something has gone wrong. We notice what we should get is x equals 3 should graph as a vertical line through 3, 0, and x equals 5 should be a vertical line through 5, 0. So you'll notice if the lines look really boring, something is probably going wrong.